Thanks everybody for joining this session. We want to present you a simple topic. Why to use a frequency drive for a water pump is saving energy, and which methods are available to regulate the flow, and how much we can save, and what the saving is depending upon. There will be some theory behind, and also a practical example from an existing machine to quantify it. Let's see how it's going on. Okay, we start from the valve in bypass. What does it mean? It means the flow, which is not demanded by the user, is recirculated back. Definitely, the pump is seeing only the same flow and the same pressure, but just the user is affected by the change. The bypass is upstream the user, and the pump is keeping the same consumption as before. Energy is lost because of that. The working point of the pump is different from the one of the user. The pump is delivering more flow than needed. The energy is lost, therefore, and the energy lost is the product between the head, which stay constant, and the delta flow here, which is represented by this difference. In case of the regulation in sequence, the valve is actually changing the flow through the pump while keeping constant delta P before the user HA. So this value is constant. This has the effect to increase delta P after the pump, and the head curve of the load changes, it becomes the green one, and the working point, which is the intersection between the first one and the head curve of the pump, moves backward. As you can see, the working point. Here also, the working point of the user and the one of the pump are different, and the energy lost is given by the product between the new flow and the head difference, as per this formula. The head difference is this difference here. In the third case, which is the regulation by means of a frequency drive, actually there is no valve, neither in parallel nor in sequence. So the drive is changing the pump speed to keep the pressure constant, the pressure before the user, this one. What happening to the load curve? Without any control, the flow drops and the pressure would raise as per the previous slide. But because of the control, so the drives reduce the speed of the pump, it means the pump is also changing its characteristic, and the new operation point is displayed here. So the working point of the user and the working point of the pump are the same, and there is no loss. Actually, there is a minimum loss due to the efficiency change of the pump and the consumption of the drive, but this is, in most of the case, negligible. From now on, there are some examples of what told above. Let's see a real pump in three different applications. The pump is from a known supplier and it is used by a machine. Normal operation means at nominal flow. The working point is the orange star. Replacing the values, we find the consumption, 13.75 kilowatt. Let's see now the bypass regulation. In this case, the demand of the user drops from 97 to 70 cubic meter per hour. But the load curve does not change, and therefore the working point seen by the pump. What has changed is the flow to the user. The consumption is still the same as before, 13.75 kilowatt, therefore there is a loss. The example of the sequence regulation, the power is reduced because we are running at a lower flow, 70 cubic meter per hour, and this is the corresponding working point in the pump curve. But we are increasing artificially the head, this difference, and also we are working where the efficiency is less than at nominal conditions. Our consumption is definitely 12.23 kilowatt. With the variable frequency, we are operating at the same flow as before, 70 cubic meter per hour, but the head is not increasing. We are still at 37 meter, and the efficiency is less than before, but not so bad as by means of the flow regulation. And eventually our consumption is landing at 11 kilowatt. The summary is that in normal operation we should have 13.75, with the bypass the same consumption because the extra flow is completely lost. In sequence we would need 12.23 kilowatt, and with frequency drive only 11 kilowatt. It means with frequency drive we can save 20% compared with bypass operation. Something less if compared with sequence operation, but still we have a saving. Thanks a lot for attending. See you next time. Bye bye.